فصلت الوصفة كويس.
I choose this lesson to demonstrate it by using the digital technology because Good afternoon everybody, speaking to you Mohamed Hammad. I am a science and chemistry teacher in Cairo, Egypt. It is a great pleasure to demonstrate my presentation to you, and it is about the matter and its structure. I choose this lesson to demonstrate it by using the digital technology because it is one of the difficult lessons to be imagined by the student, because the matter is everything has mass and volume, so everything around us is a matter. But what is the structure of this matter? And what is the difference between the different states of matter in the structure? I ask the students these questions in a warming up and receive their answers in the brainstorming strategy. Then I will start by demonstrating the first video which explains the matter and its structure from the YouTube in the first circle of the presentation.
This is an introduction to explain that we can record a voice and use it in the digital learning. Okay, now we will start the Breezy. And this is the first video to explain the structure of matter and the
states of matter. In this video you are going to learn what the three states of matter are, some examples of each state of matter, the characteristic properties of the three states of matter. The three states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either. But they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed. They are far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
Now we'll explain the properties of the molecules which consisting the matter. And the first property is that the molecules of the matter are in a state of continuous motion. And this video explains the motion when you put a piece of ink in the water. We see that the spreading of the molecules of the ink through the and this very well explained this, and it is one of the things
Hi,
that is
this is
difficult
Mary,
to
and
explain.
today we're going to talk about the
student.
spaces between molecules and how that affects measuring. What I'm going to use for my demonstration today is some colorful spherical cereal, some salt, some water, and rubbing alcohol. Both have different colors of food coloring, so they're easier to see. Another bottle for measuring, and a funnel. So let's start off over here with our colorful cereal. I'll try not to say its name, but spheres work best for this, little round balls. And you notice I have pre-measured in this 2-cup measure. This is a 2-cup liquid measure. There's about 1 cup of the cereal already, and the top 2-cup measure is up here. So I have another cup of cereal in my hand. If I were to pour it in to the glass measuring cup, 1 cup plus 1 cup, how much would you say I would have in the cup? Well, I know you would say 2 cups, and you would be right. I tried it many times. It actually works out that way. It would come about up to the 2-cup line in its lumpy, bumpy way. But that's too easy. Let's do something a little more challenging. Instead of putting in, for our 2nd cup cereal, let's put in some salt. This is exactly 1 cup of salt. Sugar and dry sand also works for this. Now, since 1 plus 1 equals 2, then 1 cup of cereal plus 1 cup of salt is going to come up to the 2-cup mark on the glass measure, right? Okay, let's see if 1 plus 1 equals 2. Oh, wait, something's not right here. Okay, you probably saw the rolled piece of cereal in there. With or without that piece of cereal, we didn't really get up to the 2-cup mark. There's only 1.5 cups of dry ingredients here. How is it that 1 plus 1 only equaled 1.5? Well, you're probably way ahead of me on this one. You probably realized ahead of time that the salt was going to fill in the spaces between the cereal pieces. And you might have been asking already, if I say I've measured a cup of cereal here, do I really have a cup of cereal? Can we count this as a cup of cereal when there are so many spaces in between? So it's pretty obvious with cereal and salt, but what about for liquids? Let's try the same thing with a couple of liquids. So over here, the blue liquid we have is water, colored blue. We have a 1/2 cup water, and I've colored some 99% rubbing alcohol yellow. 99% alcohol works best for this. And to give myself another measuring jar, I've pre-measured 1 cup. So we have a 1 cup line here. 1/2 plus 1/2 equals a whole. You've probably cooked in the kitchen and you know that 1/2 cup of water plus 1/2 cup of water is a cup of water. Let's see if that works for water and alcohol. Dyeing them different colors shows us something interesting, by the way. Notice that the yellow alcohol on top, it doesn't really want to mix with the water. It has to be coaxed a little bit. And if you swish it or stir it, it will finally, but it's going to resist. Once it's all green, you'll know that it's mixed. But look at this, just like the cereal, the liquid didn't come quite up to the 1 cup mark. Well, what's that about? Here we don't see any particles. Here we don't see any air spaces between any particles. But it turns out that alcohol and water are both made of molecules. Molecules are particles that are so small we can't see them. So even though we can't see them, there are particles with spaces in between within this liquid. And the water gets in between the larger alcohol molecules in the same way that the salt got in between the cereal pieces. So, the question I'll leave you with, if somebody fills a bottle of water, is it full? Is it, if it's a liter bottle, is it really 1 liter? Is it any more full than a bottle or a liter of large pieces of cereal would be? Food for thought, signing off.
Sorry for the long video, but it explains the main point that there is an intermolecular space between the molecules of the matter, and it is this point is difficult to imagine by the students because we not imagine that the molecules and the distance between the molecules. So this video explains that when there is a big molecules, the spaces between these big molecules can be occupied by another molecules of another substance, such as alcohol and water. Okay. The third property of the matter molecules, the intermolecular forces, and also we know that there is an intermolecular force between the molecules of the matter, and these forces are very strong between the solid molecules and very weak between the gaseous molecules and the medium between the liquid molecules. So we can separate a cup of water or amount of water into 2 portions easily, but it is difficult to separate a piece of iron because there is a strong intermolecular forces between the iron molecules. And this image explains the spaces between the molecules of the matter. And also this is a bubble us for the summary of the lesson and the properties of the matter molecules. The assessment, I will ask the students to make a chart, explain the solid and liquid and gaseous molecules and explain the properties of the molecules in each state and add it on the globe star. It is written at the address, and this is a QR. Use it for entering this globe star. Okay. Also, this is a thing link. To explain the properties of the matter molecules in each state, the solid, liquid, and gas. Okay, thank you for listening.